Dear students, in the class we are going to discuss the evaluation of double integral under the region. Already we have discussed one problem in the same topic, the last video. Now we are going to discuss the second problem. Evaluate double integral over r xy dx dy, where r is the region bounded by the parabola y square equal to x and the lines y equal to 0 and x plus y equal to 2 lying in the first quadrant. Okay, so here given integral is double integral over r xy dx dy and the region. So we have to draw the rough diagram for the region. Okay, here we draw this. X and y axis. Then we'll take the back. It is x axis. It is y axis. Y square equal to x is the parabola. This is the parabola. And then draw like this. Second one, y equal to 0. Y equal to 0 means x axis. It is y equal to 0. So y equal to 0 means x axis. And then x plus y equal to 2. X plus y equal to 2 can be written as x by 2 plus y by 2 equal to 1. It is the intercept form of the straight line. Intercept form of the straight line. And then x intercept 2, y intercept 2. Okay, if this 2 is here, then we can draw the straight line which connecting the both points. Okay. So this curve is, what is this curve? This curve equal to y square equal to x. This straight line is x plus y equal to 2. Then lying in the first quadrant. So this is the region, and then which covers that x plus y equal to 2 and y square equal to x. Is it not? So this is the region which covers that straight line and parabola which are lying in the first quadrant. This is the region R. Is it not? So in case we wish to integrate that with respect to y first, then we will draw the parallel line to y axis, keeping x as a constant. Then we can write that the integration I can be written as double integral over xy. In case if I want to integrate with respect to y first, then we have to write like that, y dxy dy dx. So first we have to, here we can write the region R. Double integral over R. In case if you draw the parallel line to y axis, what happened is, so if you draw the parallel line to y axis here, in middle, see that here, in case if you draw the parallel line to y axis, it is start from y equal to 0 and end with parabola up to this point, and then afterwards starting from that y equal to 0 end with the straight line, So there are two shapes are there, then we can write this as region 1 and region 2. So here we note that such a line does not intersect the region of intersection in the same fashion throughout. So if the line is drawn to the parallel to y axis, the first half of them in the region is started from y equal to 0 and end with the parabola, and then the remaining region R2 start from y equal to 0 and end with that straight line. So how can we write that the double integral according to this? I equal to I equal to region 1 and region 2. So region 1 plus double integral over region 2. Then how to write that the limits for region 1 and then limits for region 2. The inner value is same, xy dx dy dx, xy dy dx, xy dy dx. Now we note down the point, it is point O is 0, 0, and then this point is the intersection point 1, 0, this point is 2, 0, and then here this point is 1, 1, and then here point is 0, 2. Okay, so how can we write that the limits? First we have to write the limits for y in the region 1. Region 1 is starting from y equal to 0 to y equal to the parabola, y equal to root x. Because y square equal to x is there, then we can write that y equal to root x. What is the limit of x? Limit of x from 0 to 1, that is x equal to 0 to x equal to 1. Because we are writing that the limits for the region 1, so what are the values of that axis in the values in the axis? 0, 0 and 1, 0, 0, 0, 1, 0. So what are the values of x here? 0 and 1. So we have to write that. Next we go for that the second region. In the second region it is start from y equal to 0. If you draw the parallel to y axis, then it start from y equal to 0, end with the straight line. Straight line is x plus y equal to 2. Then we can write that y equal to 2 minus x, and then x values are from 1 to 2, x equal to 1 to x equal to 2. So this is the way you are writing that the limits for the integrator. If you are solving this value I1 I2, you will get that 3 by 8. Okay, you will solve it. In case if you are changing the order, that is if you are choosing the different order of the integration, then we can write one more alter method. We can write here that is we have to x integrate first, then we have to y integrate second. At the time we can write that I value equal to double integral over r xy dx dy. Okay, now we can see the problem here. Xy dx dy, what is the inner integration variable? X. Draw the parallel line to x axis. Now draw the parallel line. It is the alter method. In case if you draw the parallel line to x axis, what happened? It is starting from the parabola and ending with the straight line. Okay, so that region is not splitting. Region is not splitting. In case if you are integrated with respect to y first, the region is splitting into two region. But if you are integrating with respect to x first, the region is not splitting. Then we can write here the values of x is starting from parabola x equal to y square and then ending with x equal to 2 minus y, straight line. Then what is the limit of y? See that here 0 comma 0 and end with that from the region. What are the two values? It is 0 comma 1, and then you can see what are the values of y, 0 and 1 here. Therefore y equal to 0 and y equal to 1, xy dx dy. In case if you are integrating this, what you get? That is equal to, taking 1 by 2 outside and then integral over 0 to 1 and then integration of x is x square by 2, then substituting upper limit and lower limit, we will get that upper limit 2 minus y whole square minus y square is y power 4 and then dy is there. Then that is equal to 1 by 2 integral over 0 to 1, then 4y, expanding that 4y minus 4y square plus y cube minus y power 5 dy. If you are simplifying this, you will get the answer. Integrating and simplify, you will get the answer 3 by 8. So choosing that order is very important. If you are choosing the order of the integration is y here, then the region is splitting. In case if you are choosing the order x first, no need to split that integration, directly we can get the answer for this. So from this example, we note that the choice of the integration is to be made by considering the region of integration so as to simplify the evaluation. Okay. In the next class, we will see about that triple integral of the volume V. Thank you.